Swayam Prabha. Digital India. Educated India.
Now I'd like to talk to you a little bit about energy efficiency, and if you look at energy efficiency, many of the devices that we talk of for energy efficiency, for instance an energy efficient motor as compared to the standard motor, you would find that the initial cost of the energy efficient device is slightly higher, but most of these energy intensive devices, the operating cost is far exceeds the cost of the initial purchase. For instance, if you look at a 20 horsepower motor, the initial cost of a 20 horsepower motor is just 45,000 rupees. An energy efficient motor may be slightly costlier, let's say at 60,000. However, the annual cost of electricity to run that motor continuously is about 6 lakhs. And in the case of the energy efficient motor, this runs out to be 5 lakhs, and so you get much more than this benefit in terms of doing this. The problem often is that when you implement a motor, it is one of the loads of the total, so we never track what is happening in terms of the benefit that we are getting, and this is one of the difficulties which happens when this. So many of these, whether you look at incandescent lamps, boilers, the energy, the operating cost far outweighs the cost, and that is why we would like to look at it from a life cycle point of view. So this is from a German study which shows that how do we remove the obstacles for energy efficient motors, and there are a whole set of different policies which can be done. So there are, in the case of motors, there are these original equipment manufacturers. For instance, in textiles and many of these industries, they buy the process equipment where the electric motors are part of the equipment. So in this, if we can have voluntary agreements, standards and labeling, then in the case of the buying by the large industry, there are consultants, and then there are again labeling, information, subsidies and duties, campaigns for replacing inefficient equipment, again the information, auditing, environmental taxes, create incentives for new product development, marketing by motor manufacturers, so that you can have the energy efficient motor being the major stream where people rework their entire manufacturing, and then the cost differential will also come down. So there are a whole host of things, and these kind of analysis can be done for almost all the energy efficiency options. Now let's look at the last another example. Before we do that, let me look at another energy efficiency example. I talked to you about the Perform, Achieve and Trade, and this was a scheme which was launched by the Bureau of Energy Efficiency, and the idea was the large energy intensive industries were targeted as designated consumers. There were discussions with each of these stakeholders, and for all of them the total amount of energy which is being used was calculated. The specific energy consumption, that means the energy consumed per unit of product, was calculated, and there were set targets in terms of how much they should reduce the specific energy consumption. Now in this, the problem which was there is the whole industry has a set of different kinds of, there are small players, there are large players, there are efficient players, there are inefficient players, there are older companies and plants, and there are the new and efficient plants. And so the idea was that the target was distributed amongst the whole segment in a certain way, and this was done through a set of, so for each of these there was a consultation document and a process. So in the case of cement, we are looking at each of these, the output was put in terms of tons of cement, Fertilizer, it was developed in terms of tons of urea, so the energy used per ton of urea, energy used per ton of cement, energy used per ton of crude steel, sponge iron, alumina, molten aluminium, pulp, paper, fabric, yarn, caustic soda, electricity. You can look at the document for further details. So for instance, if there are a number of plants and the last 3 years of data was collected with their average production and their energy consumption, and then amongst these plants the total consumption was taken, and the best plant was taken as the relative SEC, specific energy consumption, which is the lowest, was taken as 1, and correspondingly the others were divided in terms of the ratio of the specific energy consumption. So the plant which had the highest, if this had let us say 40% higher specific energy consumption, whatever target was set overall, this would have a higher target of 1.4x, while the plant which had 1 would have only x. We add this up and then the total target was put in terms of a percentage and then attributed, divided against amongst each of these plants, so that there was a differential target, with the ones which were more inefficient having to set a higher target compared to those which are already more efficient. And in this the idea is that there would be designated consumers, there would be a nodal agency which would audit and specify what is the consumption and monitor this, and then there would be an exchange and a registry, and the market regulator would be the Bureau of Energy Efficiency. So the idea was that everyone would have over a 3-year cycle a target. If you achieve your target, that's fine. If you overachieve, you get a certificate which you can trade and sell. If you underachieve, you either buy the certificate or you pay a penalty, and this is how this was sort of proposed. The steps were that the steering committees were created and structured, and this was approved. It was approved by the cabinet, and sectoral committees were appointed, baseline data was collected, and then rules and notified and the designated consumers. So for instance, if you look at an iron and steel plant, we can look at the different kinds of processes, the total energy input, electricity, solid fuels, all of them put into an equivalent term and then divided by the production output to get the specific energy. So the idea was that it was not feasible to define a single norm, and each unit would be targeted based on its past performance and its specific energy consumption within the band of all the units in that sector. And so then if you see this, the ones which are gold will only have to save 1.5% on a 3-year basis. The ones which were inefficient will have to go as high as 7.5%. And so this is the way in which this happens. Just to give you an idea, the specific energy spread, for instance, in the pulp and paper sector, you can see there's a wide range of specific energy consumption of these 17 units, and you can see then the targets have been set accordingly. These have been clustered based on the type of feedstock or the type of product, and then targets have been set. So as I told you earlier, we have this possibility of if we meet the target, it's fine. This is the baseline, this is the target. If we are below the target, that means we've overachieved, we get certificates for this amount. If we underachieve, we can either purchase the certificates or pay the penalty, and the penalty was twice the amount of cost that would have been incurred if you had done that saving. And then there are many issues: verification by energy auditors, specific energy consumption, and the normalization factors. So this has been implemented in a certain way. The next phase is happening where this is being broadened and deepened, and the market has not yet developed, but the first stage of doing this has happened, and this has increased at least the awareness in terms of the energy consumption in the industrial sector. Another set of we talked about the renewable energy certificates, very similar to the PAT. Here what has happened is, earlier we used to have these preferential tariffs where we got, for renewable energy we would give a preference in terms of a higher feed-in tariff. Now instead of this, now the idea is that the electricity is sold at the distribution company as the price at which it would normally be bought, and you get a certificate saying that we have generated X megawatt hours of renewable energy, renewable electricity, and that renewable electricity can be sold to obligated entities which will meet their renewable purchase obligations. And this has sort of, the idea was that these certificates would be traded, but unfortunately the supply and demand matching of this was not there, so it was actually just hovering around the floor, and there was not much movement on this. But this is, as things progress, the renewable energy certificate mechanism may work. So the idea in this is that this RECs will be going to the power exchange, and the state load SLDCs, the renewable energy generators and obligated entities can work on it. We talked to you when we discussed financing. We looked at this mechanism where we were talking in terms of leasing, and I talked to you about this example of Ahmedabad Electricity Company, where you had the manufacturer actually leasing the capacitors and getting paid from the electricity bill. A similar kind of concept was adopted in the scheme for the compact fluorescent lamp, Bachat Lamp Yojana, and the idea in this was that the prices of lamps would be brought down, and it was of course based on the fact that the CERs would be sold at a price. The earliest concept of the energy service company actually dates back to James Watt and his steam engine. At that time, so this was the idea, is that we have this concept where an energy service company comes in and says that you are now paying a certain amount for your energy. We will come in and you continue to pay, you pay a little less, so you save, let's say 10%. We will implement energy efficiency as a service and we will charge you for that, and so percentage of the savings will come to us. You benefit because you are getting a lower bill. We benefit because we are getting a profit out of it. So this kind of concept has been tried, and this was earliest was in James Watt, where he says we will leave a steam engine free of charge to you. We will install these and take over for 5 years the customer service. So the whole operating risk is with this. This is especially true for new industries and steam engine. We guarantee you that the coal for the machine costs less than you spend at fodder on the horses which do the same work. So earlier it used to be horse driven mechanical work, and everything we require is that you give us a third of the money that you save. So 1/3 and 2/3, 1/3 coming to James Watt's company and 2/3 going to the company. So this is the concept of the energy service company. Somewhat successful in the Indian context, not that successful, because many of the industry, the energy service company has to get the financing and do a lot of these risks. Now let's talk about the last example, and that is about nuclear. We'll talk about nuclear. As you may know, everyone usually has a view on nuclear. Many people are positive in terms of nuclear. Some people feel that there are problems with nuclear. In the case of nuclear, from a carbon point of view, it is a low carbon option, and it doesn't have any emissions that there in terms of CO2 or local emissions. However, the problem is with radiation. These are usually large plants, and there is a containment areas, and the problems are with public acceptance, problem in the case of accidents, and in the case of accidents there is a very low probability of an accident, but if the accident occurs, there is a very high probability of damage. So the question is, from a societal viewpoint, how do you analyze that and how do you compare this? There are safety risks both in terms of the fuel cycle and the power plant. There are also problems in terms of nuclear waste disposal, of high level waste, and problems in terms of proliferation, weapons and missile materials, the advantages in terms of climate change, and there are some issues related to costs. Costs are quite high in the case of nuclear. So let us just look at some of the things, and there are some estimates of the costs of damages to persons, goods and environment, and these are in the two accidents, the Fukushima and the Chernobyl accidents. These were the kind of damages, 187 billion euros and 450 billion for Chernobyl. Now, one of the issues which has been there in terms of policy has been the liability laws. We had this agreement which was called the 123 agreement, so that we can actually be part of the nuclear suppliers group, and so that foreign companies can supply, and the question was, should we be limiting the liability? So these are the kind of operators liability and the limiting, and in the case of India, we signed an agreement where the operator liability limit is to 1,500 crores. Operator shall have a right to recourse where the nuclear incident, so the supplier liability is limited, and only the operator will have a right to recourse where the nuclear incident has resulted as a consequence of an act of the supplier or his employee, which includes supply of equipment or material with patent or latent defects or substandard services. So only if this is proved, then only there will be a liability, and this liability was limited. And so the idea was, in the Indo-US deal, was that there's a nuclear liability fund with an insurance cover, and the idea was this insurance premium will come from the electricity supply price, which means of course that it will result in an increase in the electricity use. Increase in the electricity cost. We've had the recent plants which have been there, Kudankulam, Tamil Nadu, you can see 2000 megawatts at about 17,000 crores. Jaitapur in Ratnagiri district, France, about 9.3 billion US dollars, fairly high in terms of the cost. Now what has been happening is, over a period of time, because of these perceptions and this, Japan, for instance, had a significant amount of nuclear generation, and based on the problem and the Fukushima accident, there has been a setback in terms of nuclear generation in Japan. In most of the countries, the regulation has mandated more controls, and also many of the power plant nuclear generators are not functioning, are not increasing the number of equipment. So the costs, unlike in the case of solar and wind, where you see a learning curve and the costs have been declining, you can actually see in many of these cases, the US average and the French average, that the capital cost has been increasing, and this is because of more regulations, more stringent mechanisms and control mechanisms, and you can see that this is the range minimum to maximum, and this is the kind of thing. Of course, people are talking in terms of more inherently safe nuclear reactors, and there are people are also talking in terms of breakthroughs in nuclear, both in terms of smaller reactors, and there is also research going on nuclear fusion. In our context, we've been looking at now thorium as a feed source stock, but the whole issue in the case of nuclear is a question of addressing the perception and the reality of risks, and seeing whether this is societally acceptable or whether there are options. But this could be one of the cases where we can look at nuclear to meet some of the base loads. With this, we conclude this section on energy policy. We have looked at different examples. We've talked about the framework for policies. We've looked at different kinds of policy instruments and different metrics. We've looked at air pollution. We've looked at our Paris commitments. We've looked at access, cooking, energy efficiency, PAT, and the nuclear agreements. So you can look at many other different policies which are being launched by the government and also at the international level, and you can try and put all the components that we have learned in this course to analyze these policies, and then also you can propose what would be the appropriate policies for different contexts.